Okay, so today we're gonna have a short, relatively short lecture on writing requirements. I didn't want to cover a lot of material since you're taking the exam Monday. So lecture 6 is still we are transitioning now into from the needs analysis to the concept development stage. And this first part is going to be on writing the system's requirements. Lecture 5, part 3, part 4, cover the different groups of requirements that we are going to be considering in this course. But today we're going to go and look into how to write them in terms of what are the pieces that needs to be there in order to write good requirements. So this is coming from different sources, including our textbook, chapter 5. But there's I have complemented the information for this lecture from different sources. So the agenda, we're gonna go straight to looking into specifying requirements, type of requirements, how to write good requirements, and then common problems in writing requirements. So I think we discussed this already, the difference between system design and systems analysis. So analysis is typically applied to a system that is already working in place. So we are just trying to improve the performance of these existing system. And the concept of system analysis is sometimes applied also to a system that is presumed to exist, but it's actually represented by a model. Let's say you are adding a new machine to a process. I mean, most of the process is already in place, but this new addition is something that you are not already put into, let's say, in the production floor. So you want to know what will be the impact of adding this new machine to your process. And on those scenarios, you will typically rely on a model or a computer simulation when you're trying to evaluate how is it going to help you to bring this new equipment or not into the process. So system analysis is an intrinsic part of the system design process, and that's what we are trying to focus on. We also talk about different type of requirements, right? So from the system design requirements, we have the input, output, the performance, the technology, the cost, trade-off, and the system testing requirements. So those 6 requirements that are abbreviated there at the bottom. So what we are trying to do with our requirements is to try to take that information that is passed from the customer, right, from the user's need into a clear, concise, and verifiable requirement, right? So this is the idea of the customer. They think that this is what they need in order to solve the problem. We are taking that input and we're trying to transfer that into, okay, if we're going to achieve that goal, these are the things that we have to accomplish. So I have clear, concise, verifiable requirements. Since we are in this lecture, we're focusing on the system level requirements. This is equally applicable to lower level system requirements, like in this hierarchy, for example, subsystem component level requirements and so on. A good requirement states something that is necessary, verifiable, and attainable. Okay, so to be verifiable, the requirement must state something that you can measure or verify by examination, test, or demonstration. If a requirement is not attainable, then there's no need for you to write it, right? So if something that you know it's not going to be able to achieve, or if not needed, or sometimes we write requirements that basically cancel each other. Like if you satisfy this requirement, there's no need for you to worry about these other requirements because they overlap. So we want to make sure that our system requirements are well written, but at the same time are precise in a way that we don't duplicate some of the work that we are trying to do. Many international standards, including ISO, use the shall, will, should convention when writing requirements, and they represent different things. For example, shall is requirement, is contractually binding, must be implemented, and its implementation must be verified. Okay, so this is something that we need to make sure if you write a requirement with this shall word, we know that this is a requirement that we need to check. We need to make sure that this is happening in our system. If we use will, these are facts or declaration of purpose. It's used to indicate statement of fact, which is not subject to verification. So an example could be the system will be replaced after 3 years. Most likely you are not going to be present to check whether or not that's going to happen, but that's more like a recommendation. Like when they sell you a mattress, they tell you should replace this after 10 years, right? That's the type of recommendation that is based on declaration of purpose. And then we have should, which is goals, non-mandatory provisions. These used to indicate a goal which must be addressed by the design, but is not formally verified. So, for example, the spacesuit should not impede crew mobility. There's no specific way for you to verify that unless you get some feedback from the people wearing the spacesuit in this case. Okay, so there's goals. These are the things that we need to achieve, but they're non-mandatory provisions, not formally verified. So these are the 3 words that we're going to be using to state our requirements. As you can see in the examples, how they are stated, like they're short, precise. You see the different words being implemented in each one of the examples. Here are more examples when we are talking about, let's say, a new computer system. First 3, 4 are things that you must make sure that they happen because they have the shall. Produce 8.5 by 11 inch color transparency. Printer shall print at least 10 slides per minute, and so on. And then we get into the will, which is requirement 5, will be replaced after 3 years. The shall, meaning that the life cycle cost shall be less than $20,000. So again, that's the goal. That's a long-term type of requirement. And the safer should not impede the crew mobility, again, similarly, as we show in the previous example. So more examples here. Non-mandatory or utility. So dinner should have items from each of the 5 food groups. The bridge deck should be at the same level as the road surface. 95% will be acceptable. So I'm referring to this dimension right here. So non-mandatory, mandatory, the system will not violate federal, state, or local laws, right? So need to make sure that that is happening. And the bridge deck shall stretch from bank to bank. 95% is not acceptable. So what that means is this thing, in order to work, gotta go from side to side, right? If it's not side to side, you know it's not gonna hold. So 95% in this case is not acceptable. A good requirement states something that is necessary, verifiable, and attainable. So again, I mentioned that already. To be verifiable, the requirement must state something that can be verified by examination, analysis, test, or demonstration. Statements that are subjective or that contain subjective words such as easy are not verifiable. I want my system to be effective. That's something that is very high level, unable to verify. We want to avoid those words. We want to make sure that if we can provide some type of numerical value, that'll be even better. If our requirement is not attainable, it is not point of writing it. And a good requirement should be clearly stated. What that means is if I give you a sentence to each one of you, you all going to understand the same thing. That means that the requirement is clearly stated. If I give you a requirement and some of you understand something, another group understands something different, that requirement is not well stated. So you have to make sure that it's written in a way that everybody's going to understand the same thing. If there's a doubt about the necessity of a requirement, then ask, what is the worst thing that could happen if this requirement were not included? If you don't find an answer of any consequence, then you probably don't need that requirement. Okay, so if you see there's nothing, I mean, if I don't add it, nothing's going to happen, no need for that requirement. Verification, as you write a requirement, determine how you will verify it and determine the criteria for acceptance. Okay, so something to keep in mind as you're writing the requirement, you're thinking already of how you're going to make sure that you can measure and verify that you can accept or not. This step will ensure that the requirement is verifiable. To be attainable, the requirement must be technically feasible and fit within budget, schedule, and other constraints. So we're talking about these 3 dimensions: cost, schedule, and performance. So if it's meeting those 3, then it's attainable. If you are uncertain about whether a requirement is technically feasible, conduct a research or studies to determine its feasibility. Some of you been talking about different systems for your project. I think I have raised this concern for some of you. So there's no necessarily a technology already available. Maybe it is. You have to do a little bit of research. A technology to do, let's say, one piece of your system that you are trying to incorporate. If still uncertain, then you might need to state what you want as a goal, not as a requirement. Even if a requirement is technically feasible, it might not be attainable due to budget, schedule, or order. So even, I mean, let's say you only have 2 years to complete the project. If the technology that you want to use may take 3, even though it's there, it's going to be too long for you to wait, so it's not attainable. There's no point of writing a requirement for something you cannot afford. Clarity, each requirement should express a single thought, be concise and simple. The requirement should not be misunderstood. It must be unambiguous. Simple sentences will most often suffice for a good requirement. So if your requirement definition has three lines in a Word document, that's too long, right? You want to make sure that maybe you can split it or you can make it more specific. So simple sentences. Here's some examples of misunderstandings of unambiguous thoughts, right? So this coming from Mr. Rogers, Media. Why did you pop so much corn? Only need 6 cups. And I popped 6 cups, say Media. I meant six cups of popcorn. Say Mr. Rogers, then you should have say so, right? So instead of popping all these smaller grains, right? It was referring to the actual popcorn. So make sure that those type of things are not happening. That you are thinking something, when you put it in words, people will understand them differently. You should say what you mean. I do. Alice has literally replied, at least I mean what I say. That's the same thing, you know. Not the same thing a bit. Say the Mad Hatter. Why you might just as well say, I see what I eat is the same as I eat what I see. So it's not the same. Requirements are often written qualitatively, right? So we use figures of merit to quantify them. So we encourage for most of the requirements to have some type of quantitative figure to use. As we are seeing here, we have performance figure of merit, the cost figure of merit. As we move towards the left direction, is better. We move towards the right, is worse. So we can start thinking about those type of thresholds in which we want to be for our design. Verifying and validating requirements, ensuring that the set of requirements is complete and consistent. A real-world solution can be built that satisfies the requirements, and it can be proven that real-world system satisfies the requirement. How can you validate your requirements? You can validate that based on logical argument. Like if you have taken any high-level math courses, like proofs, those are logical arguments. Inspection, modeling, simulation, data analysis, test using different type of testing or a demonstration. In summary, verification means building the system right. Validation means building the right system. Can anybody tell me the difference? When you read those two things, does that make sense? Yes.
If you can build the wrong system correctly,
Yes.
or you can build the right system.
So verification is basically saying that you're following the steps the right way, independently of the result, right? So you verify this is what I did, and I did everything the right way, and this is the final product. But maybe at the end, that final product is not the right system, right? It's not doing what it's supposed to do. But you verify and you make sure that you follow the right steps. Validation means that opposite, right? You're following the step, but also at the end you notice that you have built the right thing. The right thing.
Verification is for steps and validation is for
Yes. So you run your code and you verify that you follow all the steps. The code is giving you this output. That's the right output based on the instructions, but maybe that's not what you wanted the code to do. So you have to go and make changes to the code so it can give you the right output. Yes. Common problems in writing requirements, making bad assumptions. Okay, so if you make bad assumptions due to lack of access to sufficient information or the information does not exist. Making a bad assumption can be critical because maybe you're avoiding something that is really important to the performance. So my advice is to try to collect as much information as possible. And then based on that information, you try to gather insights from different perspectives. Writing implementation instead of requirements. Right, so specifications should state what is needed, not how it's going to be provided. So instead of thinking of the solution, you're thinking of what's needed. So you want to make sure you're stating what is needed. Now, how are you planning to solve that need? Describing operations instead of writing requirements. This problem is somewhat similar to the implementation problem, using incorrect terms. In a specification, terms must be used in a very specific manner to make sure that you follow these three as explained already. Using incorrect sentence structure or bad grammar, requirements should be easy to read and understand. Try to avoid bad grammar. This level, you have so many tools, that seeing this type of grammatically errors is quite uncommon, but you can still see them. Missing requirements. Many requirements are missed because the team writing the requirements is focused on only one part of the system. So if you can come up with an outline on areas that needs to be covered and how your requirements are going to be addressing each one of those areas, that could help. And then over specifying, stating something that is unnecessarily or stating overly stringent requirements. That's also a common problem. So you try to be so specific, then when you try to validate your system, it's not possible because those requirements, one or two of them are too difficult to satisfy. And that's the end of the lecture. Questions? Yes.
If you have a customer that has a need that is subjective and not measurable, how do you write a requirement for that? Like, if someone said, I want a car that is fashionable, you can't measure that.
Yeah, so that's a very good question. So in that sense, you're gonna have to go deeper in what the customer means by fashionable. What are the things that the customer is looking at? Is it the color of the car? Is it the I don't know, the size of the car, the interiors? So you gotta have to dig a little deeper. If you're dealing only with one person, then you gotta go and talk to that person and gather more information. You don't want to make a bad assumption, right? Because maybe for you is something else. If you're dealing with a big team, then you have to gather the impact of the different stakeholders, and they might see that differently, or they might have a different type of requirements in addition to that. Yeah, but there's no other way. You gotta have to try to understand what the customer means by that qualitative requirement, and then try to build a group of requirements that can lead you to that. Good question. Any other question? Okay, so I also have an activity that is not due today. I actually made it due the day after the exam, Wednesday after the exam. And this is to help you start thinking about what's going on? It's not projecting. Yeah. So this is lab 5, I think. Yes. So based on what we have discussed in terms of the different type of requirements, I am asking you to write 5 requirements of each category for the system that you selected for your class project. Okay, so I have, let's say for input output requirements, I'm giving you 5 spaces here. And I'm also listing some examples to guide you. So for example, input output system shall accept temperature data from a sensor, and that should be updated every 10 seconds. System shall generate PDF report summarizing. So that's more like an output type of requirement. Technology requirement, like if you are using specific coding language, that could be stated as a technology requirement. Performance here in terms of availability during peak hours. Cost is more simple, right? So development costs should not exceed this much. Maintenance costs over 5 years shall remain under this much. This one is a group that is a little bit more difficult. because we are looking at trade-off. System which will include backup servers to ensure reliability, but this will increase energy consumption and operational costs. System will be designed for simplicity to ensure quick deployment. We will need to re-architecting if usage scales beyond 1,000 users. And then system test requirements interface shall allow users to complete a form submission within 3 minutes without the need for additional instructions. So again, examples, general examples, but I need you to start thinking about these different requirements for your specific project. So I have provided you with this list. As you work on this, you're also working in your progress report. Okay, so this is kind of forcing you to do that before the deadline. So